Okay, next slide. Okay, next unit is the motion analysis. In the motion analysis, the topic says homogeneous transformation principle, application of rotation and translation problems, and the specification of matrices and DH notation joint coordinates and old coordinates and the forward and inverse kinematics of problems. Okay, here this homogeneous transformation means you can categorize the two functions. One is the homogeneous and heterogeneous function. Only homogeneous transformation means this is the identical matrices. Okay, next slide. You can go to the next slide. Next, next. Okay, this is the six-axis robotic arm. The six-axis robotic arm has the three rotations and three translations. Now, totally 6 degrees of freedom. 6 degrees of freedom is also called as the homogeneous transformation. Is applicable for the rotation and translation. Okay. Next slide. You can go to the next slide. This is the edge robot, and this is the six servo robot. Already in unit six activators functioning in the servo motor mechanism. This is the rotary functioning, and this one is the end effector. Okay, this one is the end effector function, and one is the microcontroller, and next one is the wires. This is move to the one place to another place. That is the pick and place robot. Next, you can go to the slide. Here, these are all the applications are known as the rotation and translation problems. Okay, next slide. Go to the next slide. Okay, okay. This one is the first one. This is the end effector. You can see the links and joints. Okay, here how many links, how many joints. Okay, here the joint one and link one. Here the joint two and link two application. And this is the coordinate system. These are also called as the old coordinate system. Here, the what is the differences between the old coordinate and normal coordinates means the normal coordinates position is the downward stream to upstream position. A level the ordinary coordinate, and what the old coordinate is the moving position to the upward position to the lower position. Is upward position to the lower position is called as the old coordinate old coordinate old coordinate system. Okay. Next is the what is robot. Robota meaning is the slave labor. Okay, here the human labor consisting you can save the labor. Here the 12 labors can work into the one robot system. So that is the slave labor. What is the industrial robot? The industrial robot is called as robotica manipulator or a robotic arm. Okay, in this all units you can discuss only for the robotic arm. Here nowadays you can categorize the three specializations of robotic. One is the robotic arm, second one is the humanoid, and third one is the artificial intelligence robot. In our subject, you can deal with only robotic arm. The robotic arm is similar to a human arm and can modified as a chain of rigid links interconnected by a flexible joint. Okay, here this one is the robotic flexible joint. What is the links? The links resemble the human organ like chest, upper arm, and forearm, while the joints corresponded to the shoulder, elbow, and wrist. These are the end effector parts. Okay, next slide. Okay, 1 minute. Okay, here the here already discussed about the robot. You can go to the next slide. Okay. Here the finally robot is a software controllable mechanical devices that uses sensors to guide one or more end effectors through programmed motions in a workspace in order to manipulate physical objects. Okay, what is the robot software? Here, the robot software is the how the forward, backward, upstream, and downstream level, which is the robot. For example, spray painting, like that. Next, arc welding, like that. So many arc weldings are working into the robot. Okay, here the software. Here, the number of softwares involved in the robotic. How the robot will be moved to the upstream and downstream or upside or downside or forward, backward or crosswise. He can use the robot software in a particular manner. In each industry, he can use the variable softwares are involved into the control to the robot. Okay, that is the mechanical devices that uses sensors to guide one or more end effectors through the programmed. Here the program means you can give the values to that at a time. Here the robotic move the in environment you can create the envelope. Okay, here the surrounding envelope and trajectory. Okay, that is the androids. Nowadays, in modern days, industrial robots are not androids to impress to the humans. Okay, next. Next, you can go to the next slide. Here the classifications. Okay, here the classifications also known as why I am say the classifications once again means you can know about the much more information on the 6 degrees of freedom, 5 degrees of freedom, 4 degrees of freedom, or 5 or 6 degrees of freedom on the axis structure 8 or 9 degrees of freedom. Okay, here on the basis drive technologies, hydraulic drive, electric drive, and AC, DC servo motor, and DC stepper motor, and pneumatic drive. Okay, here the in 6 units same topics, but we have mentioned the hydraulic activator, electric activator, and pneumatic activator. Is in the material handling system. You can use these terms also. And next, on the basis of configuration, on the basis of configuration, one is the Cartesian, second one is the cylindrical, and third one is the spherical robot, and fourth one is the scalar robot, and scalar robot is also known as the Serato compliance adapt to arm, and next one fourth one is the articulated. Here the in 6 degrees of freedom is known as the articulated robot, and Cartesian is the single degree and multiple degrees. Here the Cartesian cylindrical spherical. Cylindrical also is the 3 degrees of freedom. Okay, remaining spherical also 3 degrees of freedom, and scalar robot is the 6 degrees of freedom. Okay, these are the configurations. Next, on the basis of controlling, and these are points are discussed with the 60 unit. Okay, one is the point to point method, uses spot welding, and continuous path motion is the uses paint, spray arc welding are applicable to glue and sealant. Okay, these are the motion control. Here in this case, what are the characteristics involved into the basic number of degrees of freedom? First you have to observe the number of degrees of freedom. Second one, you can see the drives technology, and third one is the basis of configuration, and fourth one is the on the basis of the motion control. Here these four techniques are involved into the entire robotic system. Okay, next you can see the in detail. Next, next means here you can see the roll pitch. Next slide. Okay, here the robot specifications. Here the robot specifications means why I am saying the drawing technologies and work envelopes and motion control methods and broadly the basis of robot appearance specifications. Following for additional characteristics. Okay, here this is the characteristics. Why is the for example you can buy any mobile or a laptop just you can see the specification characteristics. So that's why you can also see the robot specification, how the robotics involved into the specific unit. Number of axis is the first one, load carrying is the capacity, and third one is the maximum speed cycle time, and fourth one is the reach and stroke. Next one, tool orientation. Next one is repeatability. Next one, precision and accuracy and operating environment. Here the number of axis means we can the axis depends upon the how many translation involved into the particular particular model, and how many joints are available, how many links are available in the particular geometry. Just in order and to mention the specification and load carrying capacity. Okay, how much load will we take the for example, in pick and place robot, here 1 kg you can the end effector can be lifted in the 1 kg or 2 kg or 3 kg. Okay, just you can mention the load capacity. And next, maximum speed or cycle time. Maximum speed means here the 800 rpm or 800 700 rpm or like that mm per. You can take the mm per second. And reach stroke. Here the reach stroke means the stroke, the end effector to the product gripping purpose is known as the reach and stroke. Next, tool orientation. Tool orientation means how much degree will be used into the particular orientation. That is called as envelope area. Repeatability means the pick and place. It means just you can pick up the one load and pick in the one load, and next again the pick up load and pick in the load, next pick up the load, pick in the load. These are the number of variations is called as the repeatability. And next one is the precision and accuracy. Here the precision means what is the differences between precision and accuracy means the true value cannot be changed, the uh, change the orientation is called as the accuracy. The value will be changed differences frequently. For example, accuracy value is the point 0.1. Next, you can go to the next experiment. You can go to the point 0.1. Next experiment, point 0.1. Here, the any experiment, the value will be given to the point 0.1. So that is the accuracy. But for example, I am taking the four batches. Batch one is the point 0.1. Batch two is the point 0.2. Batch three is the point 0.4. Batch three is the point 0.6. So that is the precision system. Okay, he can know the precision. Okay, why precision and accuracy involved in the robotic means the ja- robotic position will be differ to the one position to another position. Here, the if any damage including the value, you can know the precision value. And next, operating environment. In which area, hazardous areas, industrial areas, medical areas, like environmental or education institutions, whatever it may be, that is the operating environment. Next slide. Okay, here the axis of robotic manipulator. Here the axis, how many axis you can use in the particular. In previous slide also axis differences. Okay, here axis 1 to 3 and 4 to 6 and 7 to 11. 7 to n. Okay, so 1 to 3 is the major. It is the position of the wrist. Minor, orient the tool, and redundant means avoid the obstacle. Okay, here the robotic you can get in 7 to minus n means 7 to n means redundant as the avoid obstacles means in robotic system automated guided vehicles AGV system as the avoid the obstacles. And next, minor means orient the tool. Okay, here the spray painting, coating, like that spot welding or arc welding, continuous arc welding. Here the use the orient the tool. And next position the wrist means here the this is the pick and place robot. So these are the three differences between the axis robotic manipulator. Next one. Okay, again go to the next slide. Okay, this is also known as the end effector. This end effector is also known as the unit 2. Why I am using once again I can explain the and explain the three minor axes of the wrist means. This is also known as the roll pitch yaw method. Okay, here the roll pitch yaw method faceplate which they to attach the end effector. The end effector will be moved towards the forward or downward or backward and upward is called as the end effector. Okay, next slide. Okay, here I am also classify the what about the tool orientation means roll pitch yaw method. This is the right hand method. This is the one is the axis is the yaw method, and this is the pitch method, and this is the roll method. Okay, this is the roll method. Okay, in this system, you can use the in this system you can use the robotic right hand system and left hand system. You can use the tool system. Next one, next slide. Okay, load carrying capacity of robot depend on the size and configuration and construction and drive system. Here the robot arm is the weakest position, particularly when the arm is at maximum extension, just as in the case of a human being, and varies greatly between robots 2.2 to 5,000 kgs. This weight is the gross weight, that is the weight of the end effector, the load that is carries. Okay, here you can see the every robot has the load carrying capacity of a robot depends on the size, configuration, construction, and drive system. Here the drive system means feedback control devices, and construction means how the robot moves towards the 360 degrees or 180 degrees or 90 degrees and 45 degrees or 60 degrees. We can be calculate the configuration and which type of configuration you can want. Robot configuration means polar configuration robot system, cylindrical configuration system, and a scalar robot system, and next articulated configuration robot system. These are the robot configuration. And what is the sizes? The sizes depend upon the 2.2 kgs to 5,000 kgs will be used to the load carrying capacity. So that is the main meaning. Next, we can go to the next slide. Next, what is the cycle time? The cycle time, the time required to perform the particular periodic motion is more meaningful than the maximum tooltip speed. Okay, once again, the time required to perform a periodic motion. Periodic motion means it is the sine wave. Okay, in sine wave, we can use the periodic motion. The tool will be in the cycle in cycle position. We can know as the time required to perform a periodic motion, and it is also more meaningful than the tool tip. The tool tip means the end effector. Here this is the end effector position. Okay. Next, cycle time depends on the accuracy with which the end effector must be positioned, the weight of the payload, next the distance to be moved. Okay, here the accuracy with which the end effector must be positioned. Accuracy means it is the point one. In previous slides, I can explain the accuracy means. For example, the value is the point one. Next level point one. Next level point one. Next level point one. So these are the values are known as the accuracy values. Okay, next one. The weight of the payload. The how much weight can be loaded in the for example in previous slide also can say the 2.2 kgs to 5,000 kgs will be lifted to the weight. So that is the payload. Next, the distance to be moved. How much distance? Here in starting orientation in the year of 1956, you can move the 0 to 12 feet distance will be moved to the robot. Okay, so that is the position. Next slide. You can go to the next slide. Okay, this is the time distance. The time distance means that is the short move, long move, speed low, next maximum speed. Okay, here the speed means you can increase the speed for efficiency, or revolution per minute will be increases. For example, 200, 300, 400, 500, 600, 700. The efficiency will not be lesser than the accurate value. So we can increase the maximum up to the level only. Okay, here don't go to the much more speed into the level. Okay, next, that is the influence of distances versus speed. Next slide. Okay, this is the cylindrical robot. For example, in cylindrical robot, one is the rotation, and another one is the translation. Here the two translation, one rotation. Here you can see the symbol. See, this symbol is known as the rotation symbol, and this is the line indication with the arrow heading is called as the translation position. Here the this is the rotation symbol, and next one is the horizontal reach, horizontal stroke, and vertical reach means we can know the this is the cross diagram of the this rotational speed. The rotation will be moved to the cylindrical position. At a time, you can move the object one place to another place. This is also known as the pick and place robot. Next slide. Okay, here the repeatability. Already I say the repeatability means why you can use the repeatability, so much function, so much this function reliability design characteristics. It defined as the measure of the ability of the robot to position the tooltip in the same place is repeatedly. Here the robot can be placed into the one particular position. The position will not be change never to change because of the in this exit place, also known as the account of a backlash in gears and flexibility in the links. There occurs some repeatability errors on the order of a small fraction of mm. Okay, why am the repeatability? Repeatability means here I am in previous slides also explained the accuracy value point 0.1, point 0.1, point 0.1, point 0.1. So this is the repeatability manner. In repeatability manner, same conditions point 0.1 will be placed as the point 0.3, point 0.1 placed as the point 0.4, point 0.3 placed as the 0.2. Okay, this is not an repeatability value. So you can find out the repeatability value. Okay, so in our case, repeatability is the more important. Next, next I am already say the precision. It is the distance in the special workplace between the position of a tooltip and the next closest position. Here the closest position means in accuracy value point 0.1 and precision value is the point 0.3. So that is the closest position to which the tooltip can be positioned. Okay, next slide. Okay, you can go to the next slide. Okay, forward kinematics. Here you can enter the our topic. Next slide. Here the forward kinematics. Here the base robotic manipulators as chain. Here the joint, and one is the link, and you can use the tool. The tool means it is known as the end effector and gripper. Okay. And next an orthogonal coordinate frame. Okay, here the frame also be the I1, I2, I3. Okay, these are the component. Next slide. Okay, here the direct and indirect. Direct of forward kinematics and inverse kinematics. Here the joint angles Q1 to Qn of t. You can enter the first of all geometric link parameters will be considered, and after that you can go to the joint angles, and after that you can go to the position orientation of the end effector. Position orientation of the end effector and end effector with respect to a reference coordinate system. Okay, here the first of all you can select the geometric link. Second one, you go to the how many joint angles will be there, and next you can go to the how much positions and orientations will affect it to the end effector with respect to the reference coordinate systems, that is the xyz parameter. And next you can go to the inverse parameter. What is the differences between the inverse and forward means, forward is the forward movement acting and inverse is the inverse movement acting, but these are the two things will be happen to the two things. One is the, for example, this is the forward and this is the inverse. These are the positions to the in working areas. Okay, here this is the, these are also the position. Okay, here for example this is robot system also be the position, so this also be known as the forward and inverse kinematics also be linked. Okay, these are the step by step and involved into the together. And first once again I can explain geometric link parameter. Here the geometric link parameter and joint angles, this one is the joint angles and this one is the joint angles. Okay, and next go to the direct forward kinematics. Okay, here the direct forward kinematics, and next one is the position and orientation. Here the second and the, here the position, here this is the position and this is the orientation. Okay, this is the orientation, like this also be orientation. And next you can go to the inverse. In inverse also you can take the geometric link parameters, and this is the forward and this is the negative. Okay, this is the forward and this is the negative. Okay, that is the joint angle differences. Next one. Okay, stop. Okay, you can explain the this one as the next time, next class. Okay, here the we can see the references and bodies and how the orientation will be acting towards the mechanism. Here the in the references body will be attached to the coordinate system is explained in the another video or another next class. Okay.